solving complex equations with Adam Maths Tutor. The beginner questions are some of the easier questions that you're likely to be assessed on this topic. An equation is a mathematical statement that shows two expressions are equal. For example, 6y minus 7 is equal to 3y plus 5. A variable is a symbol usually denoted with a letter, and it represents an unknown value. To solve an equation, we need to find the value of the variable, which in this case is y, that makes the equation true, where the left-hand side of the equation is equal to the right-hand side of the equation. To solve trickier equations where the variables or the letters appear on both sides of the equation, we need to move all of the terms that involve the variable to one side of the equation and all of the constants to the other side of the equation. We can do this by moving the variables to the left-hand side of the equation and the constants to the right-hand side of the equation, or alternatively, we could do this the other way around. To move these terms around the equation, we'll use inverse operations to balance the equation. So to move the terms that have the variables to the left-hand side of the equation, I can see that 6y is already on the left-hand side, whereas 3y is on the right-hand side. To eliminate 3y from the right-hand side, I can apply the inverse operation to subtract 3y from this positive value of 3y. Because the equation is balanced, whatever I do to one side of the equation, I also have to do to the other side of the equation. 6y minus 3y is equal to 3y, and I still have the negative 7 on the left-hand side. 3y will cancel with negative 3y, which is the whole purpose of why we did this. And then we're left with positive 5 on the right-hand side of the equation. As you can see, I already have the constant of 5 on the right-hand side, so I can eliminate the negative 7 by applying the inverse operation and adding 7. Because the equation's balanced, I'll also need to add 7 to the right-hand side, leaving me with 3y on the left-hand side. 5 plus 7 gives me 12 on the right-hand side. Lastly, since 3y is equal to 12, I can eliminate 3 by applying the inverse function and dividing through by 3. So dividing by 3 on both sides of the equation leaves me with y equals 4 as my solution. You can substitute your value for y, which is 4, back into the original equation to see if it holds true where the left-hand side is equal to the right-hand side. Substituting 4 for y on the left-hand side will give me 6 lots of 4, which is 24, minus 7, and substituting 4 for y on the right-hand side will give me 3 lots of 4, which is 12, plus 5. Simplifying the left-hand side and the right-hand side gives me 17 on the left and 17 on the right. Therefore, I can see that this does hold true, and my value of 4 gives me 17 on the left-hand side, which is equal to 17 on the right-hand side. On to the next question. Again, I can start by isolating and moving the variables to the same side, which I'll do by applying the inverse and subtracting 2y from the right-hand side, which also means subtracting 2y from the left-hand side. 7y take away 2y is 5y, and rewriting the rest of the equation will give me 5y plus 28 is equal to 18. Now I can subtract 28 from the left-hand side to leave me with 5y, but I'll also need to subtract 28 from the right-hand side. 5y on the left will be equal to 18 take away 28 gives me a negative value of 10. And lastly, dividing through by 5 gives me my solution for y of negative 2. The intermediate questions have a slight increase in difficulty and are more similar to the types that appear in your exam. If you have any brackets, it's a good idea to start by multiplying these out to remove the brackets. So I'll rewrite the equation with the bracket removed. 3x minus 9 will be equal to 2x minus 8. Now, similar to the questions before, I can start by subtracting 2x from both sides. 3x take away 2x is x, and I still have negative 9 on the left-hand side, along with negative 8 on the right-hand side. I can add 9 to eliminate this from the left-hand side, leaving me with x, which is equal to negative 8 plus 9 on the right-hand side, and a solution of x equals 1. On to the next question. Notice on the right-hand side, we actually have 23 minus 2x. So if you want to eliminate the negative 2x from the right hand side to isolate the variables to the left hand side, you would have to apply the inverse operation to this, which would be to add 2x to both sides. We will still have 5 on the left hand side, but collecting like terms, positive 4x plus 2x is positive 6x, and once I've added 2x to the right hand side, I will just be left with this constant of 23. Now I have the variables isolated to the left hand side, I can eliminate the constant. Since this is a positive 5, I will need to subtract 5. Therefore 6x will be equal to, and on the right hand side, 23 take away 5 is 18. Lastly, dividing through by 6, giving me a solution for x of 18 divided by 6, which is 3. On to the advanced question, one of the trickier questions that you're likely to see in your exam. Similar to the question before, we can start by removing the bracket by expanding. Rewrite the equation with this step completed. 9x plus 5 over 2 on the left hand side is equal to 3x minus 6 on the right hand side. If you have a denominator or a fraction, you can eliminate this by applying the inverse operation. Since this is the same as dividing by 2, you can eliminate this by multiplying through by 2. If you multiply the left hand side by 2, you also have to multiply the right hand side by 2. Multiplying the left hand side by 2 will just leave me with what's on top of the fraction as my numerator, 9x plus 5, which is equal to, and multiplying both of these terms by 2 on the right hand side is 6x take away 12. Now I have something in the format similar to some of the questions that I've answered previously. Start by subtracting 6x from both sides. 9x take away 6x is 3x, and I still have the positive 5 on the left hand side along with the negative 12 on the right hand side. Subtract 5 from both sides. 3x is equal to negative 12 take away 5 is negative 17. And lastly, dividing through by 3, x is equal to negative 17 over 3. Rather than attempting to write this as a decimal, which will end up giving you a tricky recurring decimal, you are allowed to leave your answers as fractions, as long as you simplify the fraction as much as possible. Negative 17 over 3 cannot be simplified any further, so we can just leave our answer like this. Here's a question that I've completed earlier. I've made some mistakes. Pause the video and see if you can spot what they are, and either write where I've gone wrong or some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.